As a final review for college algebra. Question number 1, completing the square. In order to complete the square, we first always have to look for the leading coefficient. It must be 1. It's already there, so we don't have to worry about it. Second step is going to be moving our C. Remember that we have A, B, C. We need to move C to the other side of the equal sign by adding 4 in each side. This cancel. Now we have x squared minus 7x. We have to leave in a space for b because we need to add b there. What we're going to do to b is we're going to divide it by 2 and raise it to the second power. b is 7, so it's going to be 7 over 2 raised to the second power. 7 cannot be divided evenly by 2, so we're going to leave it like that as a fraction, and we're going to multiply 7 times 7 is going to be 49, and 2 times 2 is going to be 4. So b is going to be equals to 49 over 4, so we're going to add b in both sides of the equal sign. Whatever we do to one side, we have to do it to the other side of the equal sign. So that's what we're doing here. Maybe a 9 to separate my calculations. Now we keep on going with our factoring. I'm going to fix the right side of the equal sign. If we add in fractions, remember that we have to have the same denominator. So we have 4 here. So we need, remember there's a 1 always there. So we need to multiply top and bottom by 4 in order for us to combine that fraction, to add the fraction. So 4 times 4 is going to be 16. 4 times 1 is going to be 4. We have 49 over 4. If we add then, we're going to have 65 over 4. We cannot divide this evenly, so we're going to leave it as a fraction. So now we simplify. Here we have 65 over 4. And if we factor this trinomial, we're going to have x. Factors of x squared is going to be x and x. Bring down the first sign, is going to be negative. And negative times a positive is going to give me negative. Remember that your terms c is going to be always perfect square. So it's going to be 7 over 2, 7 over 2. This is a perfect trinomial. That means a is a perfect square and c is going to be a perfect square as well. We have 2 parentheses that are exactly the same. That has to happen every time we're working with completing the square. So we're going to say that we have 2 parentheses that are the same, and this is equals to 65 over 4. Next step is going to be a square root, both sizes. So we always have the plus and the minus. What is going to happen is 2 is going to cancel with the square root, and we have now x minus 7 over 2 equals to plus minus 65. The square root of 4 is 2. We can simplify, clean it up there a little bit. Solving for x, what we need to do is add both sides of the equal sign. 7 over 2, 7 over 2. Cancel here. So we have x is equals to 7 over 2 plus minus, I forgot the square root here, a square root of 65 over 2. And that was going to be our answer. We cannot simplify any longer because there are no like terms. Now question number 2. Solve the inequality. Express your answer in set and interval notation. So if we have 2 minus 5x absolute value greater than 4, we have to solve double. We have to make sure that we have the positive side and the negative side. Okay, the sign, the inequality sign, it has to stay in the same direction. Okay, I'm gonna take the original one and I'm gonna solve for it. 2x minus 5x greater than 4. I'm solving for x, so I'm gonna subtract 2 in both sides of the inequality. The 2 cancel. Now I have negative 5x greater than 2. We have negative 5x to be greater than 2 divided by negative 5 divided by negative 5. Every time I divide by negative or multiply by negative numbers, the sign split. So the 5 cancel with the 5. Now I have x is equals to 2 over 5 and it's going to be negative. That is one of the answers. Now the other side, I have negative 4 to be greater than 2 minus 5x, and the same thing I'm solving for x. So you're going to subtract negative 2 on both sides of the equal sign. The 2 cancel. Now I have a negative 6 to be greater than negative 5 over x. I'm going to divide by negative 5, and the same thing happens. I'm going to flip the sign. Now I have a positive 6 over 5 to be less than x. So if I take this on the number line, I have that x is less than, I'm going to more or less say that negative 2 over 5 is here, and x is going to be less than, so we're using a parenthesis because we don't have the equal sign in the bottom of the inequality. I'm going to say this one is our 0, and then 6 over 5, we're going to say it's more or less around here, 6 over 5, and we're going to read it that x is greater than 6 over 5, so it's going to go this direction. So to give that in interval notation, it's going to be from negative infinity all the way down to negative 2 over 5, parentheses, because the number is not included. We have the union with 6 over 5 that goes all the way down to the positive infinity with the parentheses, because the value is not included. And the answer in Z interval notation, Z builder notation, is going to be a curly bracket x, such a thing as x is less than negative 2 over 5, or x is greater than 5. Always we list the points from the least to the greatest. Now we can go to question number 3. Find the distance between point 1 and point 2. For that we need the formula, the distance formula, which is the square root, and we're going to have inside parentheses, and it's y2 minus y1 raised to the second power plus parentheses x2 minus x1 raised to the second power. All this is under the square root. So now I'm going to label x1, y1, x2, y2, just to make it easier. So I have the distance is equals to the square root, and now substitute my values. y2 is 7 minus y1, which is 2, raised to the second power, plus x2, which is 3, minus x1, which is Be careful every time we're using these formulas and your negative. The first negative is from the formula, the second negative is from the number. Make sure to write both of them. Distance equals to, inside the parentheses, 7 minus 2 is I'm going to have 5 raised to the second power plus I have 3 times negative times negative give me a positive. So I'm going to have 3 plus 5 is going to give me 8. And all this is raised to the second power. So I have 5 times 5 is going to be 25. So I have distance equals the square root of 25 plus 8 times 8 is 64. And this under the square root. Added together is going to give me 89. And that is your answer. Question number 4. Determine it algebraically whether the equation is symmetric with respect to the x-axis. For that, we are going to substitute all our x's by negative x. So negative 3 is going to be negative x raised to the third power plus 4 times the negative x. So the function of negative x equals to any number raised to an odd power always is going to give you a negative. If it's negative, it's going to stay negative. So negative x times negative 3 is going to give me a positive 3x cubed. And then I'm going to have plus 4 minus x. Positive and a negative give me negative, so negative 4x. After solving, we can notice that our function didn't go back to the original one. In order to get back the original one, we will need to pull out a negative number, a negative 1. So if I pull out a negative 1, it's going to be negative times, it's like dividing everything by negative 1. Positive and negative is going to give me a negative 3x cubed. Negative times negative give me a positive 4x. That's the only way that I can get back to the original function. So that means it is origin. It is symmetric with respect to the origin. So now we're going to question number 5. If a room with a perimeter of 40 feet and 12-foot walls need 10 gallons of paint, how many gallons of paint does a room with perimeter of 80 with 10-foot walls need? A little drawing will help to picture these. So if we have 40 times 12, and the other box is going to be 80, 10. The board is not helping with my drawing, which I'm not good at it anyway. So we have 80 and we have 10. This is a proportion. How we set this up? We'll say that if 40, the perimeter of 40 feet times 12, we use 10 gallons of paint. And for an 80 feet wall times 10 for the walls, how many gallons you will need. So as we cross multiply in here, it will be 10 times 80 times 10, and it will be 40 times 12x. Now we need to solve that. Inside the parenthesis is going to be 800 times 10 is going to give me 8,000 equals to 40 times 12 is going to give me 480 x. And I'm solving for x, so I'm going to divide by 480 in both sides of the equal sign. These cancel. Now I have x equals, these two can cancel, so I'm dividing 800 by 48. 800 divided by 48, and that is 16.66. 7. So more or less we can say we need 17 gallons of paint. Now we're going for question number 6. Find f of x plus h. So when they're giving you a function and they're asking you to find something else that's inside the parentheses next to the function symbol, what you need to do is substitute all your x's by that. So we have 3, we have x plus h raised to the second power plus 2 x plus h minus 4. Every time we have a parenthesis and it's raised to the second power, we can simplify anything inside. We need to write it and FOIL. Write the 2 parentheses out. And here we can distribute the 2. So plus 2 times x is going to be 2x, and 2 times h is going to be plus 2h minus 4. Now here we have to FOIL. Multiply the first term, the second term. And I like to keep this organized. X plus h equals the 3, we're going to keep it there. It's going to be the number that I'm going to distribute the last. So now I go into x times x is x squared. Then x times h is going to give me xh. And then in the middle is going to give me xh again. And h times h is going to give me h squared. And I bring the rest down. I cannot simplify, I cannot combine them because they're not a term. Or at least I'm going to keep it all together. Now I'm going to distribute, I'm going to figure my parentheses at the end here. So I'm going to distribute the 3 with every single term inside the parentheses. And I'm going to distribute the 3, but first I need to combine, I need to clean up inside the parentheses. These 2 are like terms, so I'm going to combine them. So I'm going to have 2xh, and then I'm going to multiply the 3. So I have 3 times 1 that is here is going to give me 3x squared plus 3 times the 2 here, so it's going to be 6xh. And then 3 times h squared is going to give me 3h squared plus 2x plus 2h minus 4. Now I'm going to look for common terms, like terms. So x squared is the only one, nothing to combine with. So I'm just going to rewrite it. Any term that is xh is only 1, but I have 3h squared, and I'm going to write all my higher exponents first in descendant order, the most that I can. Now that 6h xh is only 1. They have that combination, so I'm going to rewrite it. And then I only have 1 with a single x and only 1 with h all by itself and the constant. So that is going to be my answer. I don't have anything else that I can combine with. Number 7. They're asking you to find for the domain of the following function. If we have a function that is a fraction, we always have to take care of the denominator. The denominator cannot be 0 because that will make the fraction undefined. In this case, we have 2 restrictions for the domain. Our denominator cannot be 0, but it cannot be a negative number either, because we can have negative numbers inside the square root. So we're going to take the inside of the square root, which is our denominator, and we're going to equal that to be greater than 0. It cannot be equals to 0 because 0 will make the fraction undefined. So we're going to solve for x by adding x in both sides of the equal sign. Why I'm adding x and not moving the 27 to the other side? Because I want to keep my x positive. So 27 is greater than x. How I gonna give that as an interval notation? I gonna just think about the number line. And we have 0 somewhere. Then we have 5, 10, 15, 20, 25, 30. We're going to say the 30 is here. So 27 should be somewhere around here. And if we're going to read in the right way, we're going to say that x is less than 27. X is less than, so it's going to go that way. That way is a negative infinitive. So my interval notation for it is going to be negative infinitive until 27, and the value cannot be included because it will make it 0. So that is our answer. Now we go to question number 8. Given the function, list the x-intercepts, if any. So we're going to write the numerator, which is the top, the fraction, and I'm going to factor. X squared is going to be x and x. Bring down the first sign, which is positive, to figure out the second sign. We'll multiply positive and a negative, give me negative. So I know that I need to subtract because the signs are different. Factors of 21 is going to be 1 and 21, 2 doesn't have, 3 is going to be 3 and 7. If you think about subtracting, 7 minus 3 is going to give me 4, which is the number that I'm looking for to match. So I'm going to do 7 and 3. I need a higher number first because I need to match the positive 4. If I write this on top of the denominator, you guys can tell they have 2 parentheses that are exactly the same. So I'm going to cancel them, and my answer is going to be x plus 7. If I solve for it, I'm going to equal that to 0. I'm going to subtract 7 in each side of the equal sign, and I have x is equals to 7. That is my answer. I cannot use the positive 3 as an answer because that will make the denominator 0 and will make the whole function undefined. So my only one answer is positive 7. Question number 9. Use the graph to find the intervals on which it is increasing, decreasing, or constant. We don't have no constant. Constant will be something it goes up or down and then it stays flat for a little bit. We don't have no flat in here. So no constant. We do have increasing. If we think about anything that is coming from here is going to be a negative infinitive, and anything that it goes and it stays like going to the right side is going to be the positive infinitive, and we're only looking at the x-axis when we are thinking or looking for the increasing or decreasing. So we're going to look at our values for the x-axis. I can see that my graph is increasing from the negative infinitive, and it start going down here. So remember, we were looking at our x values, and it's really close to 2, so I'm going to say 1.9 negative. So it's increasing from the negative infinitive until 1.9, and it starts decreasing at that point. And then it's going to be decreasing from 1.9, it's going to go all the way down until here, which is about 1.9 from the positive side. So negative 1.9 all the way down to the positive 1.9. And then it starts increasing again from the same point to the positive infinitive. So we have two different points for increasing. It's going to be from positive 1.9 all the way to the positive infinitive. That will be the sections where the graphs are increasing and decreasing. Now question number 10. Okay, you're trying to fence in a garden with 30 feet of fencing. If the length of the garden is to be x feet, express the area a of x of the garden as a function of x. Okay, the length is going to be equals to x, and we have the area. They want us to do the area of x, and the perimeter, they're talking about 30 feet. And we think about our perimeter formula is c 2 times the length plus 2 times the width. So they want us to use x. Every time we use x and y. We have the perimeter to be 30, and that will be equals to 2x plus 2y. And if we start solving for y, so we need to subtract 2x in both sides of the equal sign. So we're going to have negative 2x plus 30 equals to 2y. We divide by 2 in both sides. The 2 cancel. I'm going to flip this around so it's easier to do. So now we have y equals negative 2x plus 30 all divided by 2. So we have y equals 2 divided by 2 is going to give me 1, and 15 divided by 2 is 30 divided, I went ahead, 30 divided by 2 is going to be 15. So having y, I can go ahead and use that and substitute in my area. Sorry, I didn't finish. Area is length times width. So if I have y already, f of x. I can substitute all that in here, and it says that I have x times, I can substitute y, and y is equals to negative 2x plus 15 is a sold piece. It's going to be x times 2. Negative 2 is going to be negative 2x squared plus 15x. And that is the area represented as x, a of x. Question 11. A factory finds it has revenue as a function of price given by the following equation. So we have revenue as a function of P equals to negative 4P squared plus 100P. What is the maximum revenue the factory has, and at what price does this occur? So if we're looking for the price, we are going to think about the vertex. The vertex is negative B over 2A, and we know that B, A is equals to negative 4, and B is equals to 100. B is equals to 100. To find the price, so I'm gonna substitute B. B is gonna be negative 100 over 2 times A is negative 4 and negative 4. So I have negative 100 over a negative 8, which equals to 25 over 2. That's the maximum price. Now we're going to substitute that in our revenue equation to find the maximum revenue. So if I have R of 25 over 2 at negative 4, B is going to be 25 over 2 raised to the second power plus 100 times 25 over 2, and all that can be put in the calculator. That is going to give me 625 over 4, and we have a negative 4 here, so these two 4s are going to cancel each other out, and I have here 25 divided by 2 times 50 is going to give me a 1250. As I simplify this, I'm going to figure out that my revenue is 625. That's the total revenue, the maximum revenue. A projectile is fired 1,000 feet above the ground at 45-degree angle. The height follows the equation, so we have the equation for the height in function of x, and it's going to be negative a over 500 x squared plus x plus 1,000 where x is the distance. So x is equal to our distance on the cliff. What is the maximum height? So we're looking for the maximum height of the projectile reaches. How far is from the cliff at the point? So we need to think about this. If we have a mountain, right, or a cliff, and this is 1,000 feet high, and we fire a projectile. Think about, they're talking about 45-degree angle. So if we think about a 90-degree angle, right? Half of 90 is 45. We're throwing something like this. Because the function is a square, we know we're going to make something close to a parabola or half a parabola, and it's negative at the beginning, so we know it's going to go down. To find the maximum height, it will be here, which is the vertex. The vertex formula is negative b over 2a. So if we're looking at, our function a is going to be equals to negative a over 500 squared. B is equals to 1. So we need to plug those numbers into the vertex equation. So it's going to be negative times negative is going to be a positive, so it's going to be 8 over, I have 1, and it's 2 times. So it's going to be 2 times negative a. I got something wrong. Oh, b is 1. Where did I put b is 1? I was looking to the wrong thing. B is 1, and a is down here. It's negative a over 500 squared. So I'm going to multiply the 2. We multiply straight across. That means like this. So I'm going to leave the 1 alone for now. 2 times a is going to give me 16 over 500. I'm going to leave it for now like that. It's going to give me a huge number. So now what is happening is that I'm dividing a fraction with a fraction. You have to remember that one have a 1 down here. So I cannot divide a fraction with a fraction, so I'm going to do a skip flip multiply. So now I'm going to have a multiplication and I flip it. So the 500 squared is going to be on the top over 16. And this really is just a calculator problem. If you put that in your calculator, you're going to get 250,000. In here, anything multiplied by 1 is going to give you the same thing, so we don't worry about that 1 anymore. So we're going to have 250,000 over 16, and when we divide that, we're going to get 15,625. That's the maximum point of the projectile. Then to find the second question, which is how far, the distance is x, so we have to find x to find how far it went from the cliff. So to find x, we are gonna, I'm gonna leave it here. The distance. We're finding here x. Now with the x, we're gonna plug it back in this formula, and we're gonna find h, which is the height. If we have the original, it's here h, and we're gonna substitute the 15 625 for every x. Negative a 500 squared, and here we're going to have the 15 625 squared plus 15 625 plus 1000. No. 625. If you put all that in your calculator, you will get 24,437.50. That will be the maximum height. 13. Form a polynomial of degree 4 with the following zeros. When they give you the zeros, you have to think about we have to go backwards. 1 and 1. That's the final answer. And remember that this is coming from x plus 4 equals 0. When you solve for this, you will get negative 4. So we're going backwards with each 0. So we have x equals to negative 2. So we have to add 2 on both sides. So we have x plus 2 equals to 0 because this cancel. Now think about this. We're going one more step forward and we put this in parentheses. So we have to do this with every single 0. It's going to be equals. X is going to be, okay, x is going to be equals to 1. We subtract 1 in both sides of the equal sign. This cancel. Now we have x negative 1 equals to 0. And we're going to put this inside parentheses. The same thing happened with last one. We have 2 of them, so I'm not going to do a double. And this one is going to be x plus 4 inside parentheses. So we are forming a polynomial function of degree 4. So that means we need to use the function symbol. And we have x plus 4, parentheses, x plus 2, parentheses, a minus x minus 1, and this is to the second power. Now we need to solve them. I'm going to start by doing the double parentheses. The one is double, plus 4, and here I have x plus 2, and then I'm going to write my x minus 1, x minus 1, and I need to start distributing. So I have to do FOIL here, here, and here, and then I'm going to do the second parenthesis as well. So x times x is going to give me x squared, x plus 2 is going to give me 2x, and then x4, and then 4x, and then 4 times 2 is 8. And then the second parenthesis is x times x, x squared. X times 1 is going to give me negative x. Negative 1 times x is going to give me negative 1. Negative 1 times a negative 1 gives me positive 1. So now I'm going to combine like terms inside the parentheses. X squared doesn't have any other square, so I cannot combine it with anything. And here I have 2 x's with exponent 1. Means I can combine them. They're like terms. It's going to give me 6x plus 8. And then here I have x squared. And the 2 middle terms I can combine, so that's going to give me negative 2x plus 1. Now I need to do FOIL between those two. So I'm going to do x squared times every single term. There is a 1. So I have x squared times x squared is going to give me x to the fourth power, and then x squared times a negative 2x is going to give me negative 2x to the third power, and then x squared times 1 is going to give me x squared. Now I'm going to do second term 6x times each one of the next parentheses, and that is going to give me 6x times 1 is going to give me 6 x to the third power because I add the exponents, and then 6x times a negative 2 is going to give me a negative 12x squared. 6x times 1 is going to give me 6x. Now I need to do the last term. So I'm going to have a multiplying each term, the last parentheses, and that is going to give me a x squared minus 16x plus 8. Now I need to look for like terms so I can combine them. These two are alike, and I have the square here, the square here, and here. So I'm going to start with the highest degree. The only one with the x to the fourth is this one, so I'm only going to bring it down. I don't need to do anything to it. Then I'm going to look for my x cubed, different signs. I subtract the sign of the largest number. 6 minus 2 is going to be 4x cubed. Now my x squared, I have 12x, and I have 9. I have negative 12, and I have 9 positive. So that's going to give me negative 3. So I have negative 3x squared, and then my single x's, I have this one and this one. So I'm going to combine them different signs. Subtract, keep the sign of the largest number. It's going to be a negative 10x, and this one is only constant, so it's going to be plus a. And that is my function. Trigonometric function of degree 4. Now, question 14. Solve the inequality and express the solution in interval and set notation. So here, as I have as a common term 3 and x squared. If I divide by 3 x squared, 15 divided by 3 is going to be 5. X cancels with x squared cancels with x squared. So I have let me write this. The greatest common factor goes here, and then I'm going to have 5. Negative 9 divided by 3 is going to be 3. 2 x's cancel. 2 x's cancel with 2, and I still have 1 here. So I have x. All these greater than 0. So I need to think about my number line. I have 0. I'll think about a positive number and negative numbers. Which one are going to be the section that is greater than 0? So we're going to test this. If I solve for x, this is going to give me 3x squared greater than 0. So I divide by 3, divide by 3. 3 cancel, and now I have x squared to be greater or equals than 0. If I square root both sides, square root of 0, so that is going to give me 0. So I have x greater than 0. So that's one of the points that I'm going to look for. And the other one is 5 negative 3x greater than 0. So I'm going to subtract 5 on both sides of the equal sign. 5 cancel. Now have negative 3x to be greater than negative 5. And I divide by negative 3 both sides. When I divide by a negative or multiply by the negative number, flip the sign. So 3 cancel with the 3. Now I have x is less than 5 over 3. If we put that in the number line, it's going to be somewhere around here. 5 over 3. So we have to make a box and kind of figure out which ones are going to be the numbers that work. So I'm going to pick a number that is less than. So I'm going to use negative 1. A number in between. So I can use half. And a number that is outside the range. And I use 2. So I substitute those numbers in here. I'm going to start with a negative 1. I'm going to have 3 negative 1 raised to the second power. And then I have 5 minus 3 minus 1. If I solve for that, I'm going to have 3 negative 1 times negative 1 gives me positive 1. 3 times 1 is going to be 3. And inside the big parentheses, I have here negatives and negatives give me positive. So I have 5 plus 3. This is going to give me 8. And 3 times 8 is 24. And then I'm going to do the same thing, but I'm going to use the half. So I have 3 half raised to the second power, 5 minus 3, and I have half. So 1 times 1 is going to be 1, and 2 times 2 is going to be 4. So that is going to give me 3 times 1 is 3 over 4. And then inside the parentheses, I have 3 times 1 is 3 over 2. So I have 5 minus 3 over 2. In order for me to combine them, I have to multiply top and bottom by 2. Here's imaginary 1, so it's going to be 10. I have 3 over 4, and here's going to be 10 over 2 minus 3 over 2. So I can subtract them, so I still have the 3 over 4 outside. 10 minus 3 is going to be 7 over 2. If I distribute this, I'm going to get 21 over 8. Last one is going to be 2, so I have 2 squared. I have 5 minus 3, 2. So 2 times 2 is 4, 3 times 4 is 12. And I have here 6, so it's going to give me 5 minus 6. So my final is going to be a negative 1, which is equals to a negative 12. So what we're really looking for is to find here in the graph So when we substitute -1 in our equation, we got it 24, which is a positive number, and that's what we're looking for. We're looking for the inequality to be greater than 0. So this gives me a positive number. That's what we're looking for, greater than 0. Then we substitute by half, and we got a positive number, 21/8. So that says positive, which is good. That's what we're looking for. And when we replace the x's by 2, we got a -12. We are not looking for that. That's negative. So the 2 didn't work. So that means that our answer is going to be from -infinity all the way to 0, not including the values, with a union of 0, not including the value, all the way to 5/3, not including the values. And the set builder notation, this is the interval notation. Set builder is going to be x, such a thing as x to be less than 0, or x to be, give me just a second, or x to be in between x to be in between 0 and 5/3, and we'll close the curly bracket. So question 15, vertical asymptote. When we need to find the vertical asymptote, we look at the denominator. We have to equal this to 0, and we're going to factor. Open a set of parentheses, factors of x squared is going to be x and x. To figure out the first sign, you just bring it down. To figure out the second one, you multiply negatives and negatives, give me positive, and we're going to look for the factors of 12. So 1 times 12, 2 times 6, the signs are different, so we know that we need to subtract to find to match the middle term, which is a -1. So we have 3 times 4. If we subtract them, we get 1. So I need to place the higher number first because I need to match the sign, and then the 3. So my vertical asymptote, to find it, I need to equal each parenthesis to 0 and solve for it. So I'm going to add 4, both sides of the equal sign. That is going to cancel. Now I have x equals 4. Here I'm going to subtract 3 on both sides of the equal sign. And I have x is equals to -3. So those 2 points are my vertical asymptote. Now for number 16, we have been asked to find the horizontal asymptote. This one is set up a little tricky. We have to look for the leading coefficient, the degree. If they are the same, what we need to do is divide the coefficient of the leading terms. They have been placed in a different order, but we need to rewrite it. We can rewrite it 3/2, and the 2 is negative, so it's going to be a negative. Y equals -3/2, and that's our horizontal asymptote. Then for question 17, we have been asked to find the oblique asymptote. For this one, we have to do long division. So we're going to set our long division. 2x plus 3x plus 4. What we need to do here is to figure out by which number and variable we need to multiply the first term here to cancel the first term inside here. So if we multiply by 2. 2 times 1 is going to be 2, and x times x is going to give me x squared. So 2x squared, and remember that always we need to multiply by a negative. We're going to flip the sign at the end, and then we multiply by 2 times 5 gives me x positive 10, x. Guys, now we're going to distribute the negative. So negative times a positive is going to give me a negative, and negative times a positive is going to give me a negative. So the idea was to cancel the first term, and that is happening. Now the second term, we are going to combine them. We're going to add them, equal signs, we add it, and keep the sign, so it's going to be 13x, and now we're going to bring down the last term. Now we need to find by which number we're going to multiply. Okay, the sign I changed it to be negative, but I still can see the positive, so I did positive for the negative. So really we need to subtract. As we have different signs, we subtract, give the sign of the largest numbers. 10 minus 3 is going to give me a negative 7. Now to cancel the first term, we will need to multiply by a negative 7. So negative 7 times x is going to give me a negative 7x. And then I multiply by the second term, negative and a positive is going to give me a negative. 7 times 5 is going to give me 35. Remember that we always have to flip the signs. So we're going to multiply by negative 1. The first term is going to be positive 7x, negative and a positive is going to give me positive 35. The first term cancel. Now I have 39. So my answer is going to be y equals 2x minus 7. That's my oblique asymptote. It's going to be a y 2x minus 7. Question 18. They're asking us to find the function of f and g such that f of g equals h. Remember that we always put the second one into the first one, so we put g into f. So we're going to inverse that. We're going to separate them and figure out what they were originally before we combine them. If I put g into f, so I'm guessing that we have f, we have a fraction, so we have 1 over x. This is a function. That's my x, f of x. And for g, if I put g into f, most likely g was 2x squared plus 4. And you think about it, and they give you f and g, and they're asking you to put g into f, you will have done something like this. If they're giving you these two functions, you will have done 1 over 2x squared plus 4, which is taking you back to the h function. I'm trying to do this. Okay. Now next question, 19. We have to do the same thing. Mm, 1 over 2x plus 19. Okay, question 19 is repeated, so we're going to number 20. Graph the following function. Okay, it was a mistake here, so I'm gonna give you a different one. Forget about this one. I'm gonna write a different example. So h of x I don't know. Okay. Let me try a better root. Okay. The fourth root of x minus 2. This is another nice example to practice the functions, the h function. So if they're asking me to give back the original f and g, I'm going to do the same thing that I did before. I'm going to imagine that my f function, since I have to put g into f, was the main one. If I put one into the other one, the house, the grouping symbol, which in this case is going to be the fourth root, is going to be the original one, and I put g into that one, so g must be what is inside of the square root, which is this. So that would be the answer. Now we're going to question number 20. Draw the following function as a solid line and its inverse as a dashed line. Okay, we're first going to find the inverse and then we're going to graph. The inverse, the first step is to change the function symbol for a y. So we have y equals 2x cubed minus 16. Second step is to switch x with y. So we have x equals 2y cubed minus 16. And now we're going to solve for y. We're going to add 16 on both sides of the equal sign. This cancel. Now we have x plus 16 equals to 2y cubed. Now we're going to divide by 2 both sides. 2 cancel. Now we have the y cubed is equals to x plus 16 all over 2. In order for me to solve this, because I'm looking for y, not for y cubed, I'm going to cube root both sides. So the cube and this goes away. Now I have the y is equals to the cube root of x plus 16 over 2. The last step for the inverse is going to be to change the y for the inverse symbol, which is f of x raised to the negative 1. We're going to have the cube root of x plus 16 all divided by 2, and this is our inverse. To graph it, the best thing that you can do is go to your calculator. You can input the information in y equals, and you're gonna maybe change the color or the thickness of the line so you can see the difference between the original one and the inverse. We have y by x. I'm gonna go more or less by 2, 2, 4, 6, 8, 10, 12, 15, 14, 16, 2, 4, 6, 8, 10, 12, 15, 16, 2, 4, 6, 2, 4, 6, and I'm gonna do green, our inverse. This one is gonna be green. So more or less is coming under from the negative side. It's going to be up a little bit, and here it's going to cross. Then in black I'm going to do the original one, and that is coming, and down here crosses around here. So this is the function f of x, and this one is my inverse. And the negative 1. So question 21. Solve the equation. As soon as I see this, I can tell that I have 4 as a common factor in all of my terms. So this is multiplication. Now we have 64 raised to the 4th minus 8 equals to 1 over 16. I just rewrite it away. It's easy to my eyes to see and understand this. So and I can rewrite 16 as 4 raised to the 2nd power, and I already have the 3x as an exponent, so they're going to be multiplying each other. And 64 is the same thing as writing 4 raised to the 3rd power, and I have to take care of the exponents that were already there. And 16, I can flip that fraction and say that it's 4. Because I flip it, the exponent has to be negative. Now the base of every single term is 4, so that means I can cancel all of them, and the exponents are going to come down. So now I have 2, 3x, and remember all this is multiplying, so I have 3, 4 minus x, and this is equals to a negative 2. So I will solve for these. I'm going to distribute everyone in here. So I have 2 times 3 is going to be 6x, and then I have 3 times, remember, they're the exponents. When you multiply, you add exponents. So the exponents are they're coming down and they are adding each other. So now I got this 3. So 3 times 4 is 12 minus 3 times x is negative 3x equals to a negative 2. So I'm now going to combine like terms. I have 6x minus 3x, that's going to give me a 3x. 3x, and I have plus 12 equals to negative 2. So I'm solving for x. I'm going to subtract 12 on both sides. This cancel. Now I have 3x equals to a negative 14. I divide by 3. Both sides of the equal sign. The 3 cancel. Now I have x equals negative 14 over 3. Find the domain of the function f of x, natural log of 10 minus 2x. Natural logs, we have a restriction that it needs to be greater than 0, so we cannot be included. So what we're going to do is we're going to write the natural log, and we're going to solve for x, saying that it has to be greater than 0. We want to subtract 10 on both sides of the inequality sign. 10 cancel. Now we have a negative 2x greater than a negative 10. We divide by negative 2, both sides. That means our inequality sign is going to flip, because every time we multiply or divide by a negative sign, we have to flip it. 2 cancel. Now we have that x is less than 5. So as we go to a number line, we're going to have 0. 1, 2, 3, 4, 5. And think about your negative infinity is here and your positive infinity is to the right. And we're going to read this as x is less than 5. So our answer is going to be negative infinity all the way to 5. Question 23. Solve the equation. So we have a log in here. We have to remember all the rules for log. So the base is always going to be the base. The base is right here, log of 4. The number that is to the right of the equal sign is going to come here as the exponent of the base. And what we have here right next to the log is going to go to the other side of the equal sign. X squared minus 6x. Now we're going to solve. 4 times 4 is 16, so we have 16 is equals to a negative, equals to x squared minus 6x. And we're solving as any regular equation now. So we're going to subtract 16 in both sides of the equal sign. That cancels. Now we have 0 is equals, let me see here, x squared minus 6x minus 16. We need to factor. Factors of x squared is going to be x and x. To figure out the first sign, we just bring it down, negative. To figure out the second one, we multiply negative and negative in a positive. Factors of 16, because the signs are different, subtracted, are going to give me negative 6. So I always start with 1. 1 times 16, 2 times a. If I subtract it, I will get 6. So it has to be negative positive to match the negative sign here. So A and C, 2. Thinking about the 6 as we solve. So is we equal each parenthesis to 0. And solve for plus A plus A. So now we have x equals to a, negative 2, negative 2, the 2 cancel. Now we have x equals negative 2. And that's it. That is our answer. Now, question 24. Solve the equation. We're solving for x. In order to do that, we are going to subtract 3 3 plus 6 natural log of x equals to 12. I'm going to subtract 3 in both sides of the equal sign. 3 cancel. Now I have 6 natural log of x equals to 9. I'm gonna divide by 6 both sides of the equal sign. This cancel, and I have natural log of 6 equals to, I divide by 3 top and bottom. I'm gonna have 3 over 2. To cancel the natural log, I'm gonna use e. Both sides of the equal sign, they cancel each other out. I have x is equals to e raised to the 2 over 3. And that is your answer. Now question 25. Solve the equation. I have e raised to the x minus 2 equals to 4. In order for us to bring down the exponents, so we can work it out, solve like a regular equation, we need to cancel e with ln, which is a natural log. I'll do something different. Natural log. So these cancel each other out. The exponent comes down to minus x equals the natural log of 4. I'm going to add 2 on both sides. This cancel, now I have x is equals to natural log plus 2. And that is your answer. Write the following as the sum and or difference of logs. Express powers of factors. So I have log base 3, 9 over 6, base 3, I have 9, 3, 6x. All this is over y to the third power. When we have division, that means we have to change it back as a subtraction. And we have the same log with the same base. So the numerator, the top, is going to stay the same. And the numerator, I'm going to bring it up. And I'm going to subtract log of the same base y to the third power. Now the 9 and the square root are multiplying each other. When I have a multiplication, that means it's addition, with the same log and the same base. So that means that I have log base 3 9 plus log base 3 square root 6 of x minus the exponents. We need to bring them to the front of the log. I have negative 3 log base 3 of y. Now, if you put in your calculator log you go log, and we have different of bases, so you have to do log 9 close parenthesis dividing log 3 because that's the base, close parenthesis, enter. That is going to give you 2. I'm going to write you here on the side in blue how you have to do it in the calculator. Log, and you're going to do 9 over log 3 because that's the base. That is log base 3 of 9. You put it this way in the calculator and it's going to give you 2. So now we're going to solve the first one, the first log, which is 2, plus log base 3, the fifth root of x, minus 3 log base 3 y, and that is going to be your answer. Question 27. Calculate the following logarithm. Okay, for this one, you just go to the calculator and we're gonna do the same thing that we did before. Log base 4, 11.5. We're going to put in the calculator log 11.5 over log 4, which is the base. There we go. Log 11.5 close parenthesis divide log 4 close parenthesis enter, and that is going to give you an approximation. Question 29. A population obeys the equation P of t equals 400e raised to the 0.3t, which t in years. It's important to keep our information. T is going to be in years. How many years will take the population to reach? So we're looking for when the population, how long it's going to take, in which year the population is going to reach 1,200. So we're really looking for time in years. So we're going to rewrite our equation. P of t 400 e raised to the 0.3t is we're looking for when the population reached 1,200. So we're going to substitute our population, which is p, by the number given, and then we're going to solve for t, which is the time. So in order for solve, first I need to solve for e, first variable. So I'm going to divide by 400 both sides of the equal sign. This cancel. Every 0 can cancel with every 0, so 12 divided by 4 is going to give me 3. Now I have e raised to the 0.3t. To cancel e, I use ln, natural log. They cancel each other out. Now I have natural log of 3 equals to 0.3t. Now I need to divide by 0.3 both sides of the equal sign. This cancel. Now I have that t is equals to natural log of 3 over 0.3. And if I solve that, t is equals to natural log of 3. You put that in your calculator, it's going to give you 1.0986. All that is over 0.3. Means we divide those two numbers, divided by 0.03. T is equals to 3.66. And we have to give this in years. So we can say an approximation of 4 years. Question 30. How long will it take a sample? How long will a sample take radioactive substances to decay to half its original amount if it decays according to the function? So half of the amount. T is in years. Decay half, that's the key here. Half of it. So half is going to be dividing it by 2, finding the half of it. And this symbol is the original amount. That is represented by the original amount. So we're going to substitute our a of t by half. So we go to the original function, substitute this by half, and then we have to solve for t because that's what we're looking for. How long it will take? That's the question, in years. So negative 0.2t. First I'm going to divide by 400. both sides of the equal sign. You can put that in your calculator. This is going to give you 200. Cancel. E raised to the 0.2p. In order for us to cancel that the e, we have to use natural log both sides. These cancel each other out. Now we are going to have a natural log of 200 equals to a negative 0.2t. Divide this by negative 0.2, negative 0.2, this cancel, and I have t is equals to the natural log of 200 divided by a negative 0.2. And that's your answer.